The third cluster, use place value strategies to add and subtract whole numbers, focuses on standards NBT1, NBT2, NBT7, and NBT4. Now read cluster 3. Use place value strategies to add and subtract whole numbers in the instructional framework, pages 8 through 10. Let's take a minute now to read about NBT1, NBT2, NBT7, and NBT4 in the Unpacking document, pages 9 through 11. There have been some revisions to the NBT standards for 4th grade. Previously, 4th grade worked with numbers up to 1 million. The new standards, however, limit the number range for place value to numbers up to and including 100,000. Fourth grade students come with a background of knowledge from 2nd grade of reading and writing numbers up to 1,000, as well as comparing 2 three-digit numbers. They continue place value work up to 1,000 in 3rd grade, but it is incorporated through practice with various addition and subtraction strategies. In standard NBT4, like the place value standards discussed previously, students in 4th grade are only asked to add and subtract numbers up to and including 100,000. They will do this using the standard algorithm with place value understanding, which we will discuss in an upcoming slide. OA3 addresses two-step problems involving the 4 operations. In this cluster, you will only focus on problems that involve addition and subtraction. Estimation strategies are an important part of this standard. Please refer to the Estimation Strategies handout in the 4th grade Quarter 2 Just-in-Time folder to look at estimation strategies for addition and subtraction that you will want to teach your students during this cluster. Students have had previous work in both 2nd and 3rd grades with adding and subtracting numbers up to and including 1,000 using many different strategies. 4th grade is the first year students are expected to use and gain proficiency with the standard algorithms for both addition and subtraction with place value understanding. Caution. While algorithms can be an efficient way to operate with large numbers, teachers often forget the importance of connecting procedures to place value in order to build conceptual understanding. Do not use mnemonic devices, songs, and tricks to help students learn the steps in the algorithm, as they do not help develop place value understanding for the student. It is imperative that students know why the steps in a procedure work and how each one is connected to place value and the alternative strategies they have used previously. Remember that while students in 4th grade are asked to be proficient with algorithms, other strategies are still appropriate for students to use. The links above are videos that show one way to connect the algorithm to place value understanding. It is important for students to remain flexible in their strategies, depending on the situation and the problem they are solving. Look at the 2 problems on the slide. In which problem might a student want to use the standard algorithm? Why? In which problem would the standard algorithm be less efficient? Why? In the problem 399 plus 499, the standard algorithm is not efficient because the numbers are so close to the next 100. Students should be able to mentally reason that 399 is close to 400, and 499 is close to 500. Then subtract out the 2 that were added by making a friendly number. The problem on the right, however, has much larger numbers that are more difficult to work with mentally, and the algorithm would be appropriate in this situation. Cluster 3 includes 2 supporting standards. The first standard is MD8, which involves solving word problems involving addition and subtraction of time intervals that cross the hour. In this standards, students will add and subtract to find elapsed time in given word problems. This standard fits in well with MBT 4, addition and subtraction of whole numbers up to and including 100,000. Be sure to include problems with elapsed time across the hour with your instruction in this cluster. Another supporting standard for Cluster 3 is OA1. Interpret a multiplication equation as comparison. Multiply or divide to solve word problems involving multiplicative comparisons using models and equations with a symbol for the unknown. Distinguish multiplicative comparison from additive comparison. Conceptual understanding of place value is dependent on building a foundation of multiplicative comparison and is the foundation of addition and subtraction algorithms. Our place value system is a base 10 system, meaning that each successive unit is 10 times larger than the previous one. Students need to understand that the left is 2 times as much as the one before it, and the place value to the right is 10 times smaller. These connections can and should be explored with place value blocks.